Hello everyone. Today we're going to do the lab called resistivity of nichrome wire. Let's take a look. Okay, recall that last experiment where we took a piece of this nichrome wire, nickel chromium wire, and we submerged it in some water to use it to heat up some water. This time what we're going to do is try to figure out the resistivity of it, and we have a piece of that wire tacked down to this board right here, and we're going to run some current through it and measure the current as a function of its length and determine the resistivity of the wire. Alright, first thing then we need to do is measure the diameter of the wire. We can do that with a device called a caliper, which can measure very thin things. Here we have the caliper clamped down on the very thin wire, and its diameter is 0.0318 centimeters. 0.0318 centimeters. All right, let's write that in our data table. 0.0318. Now that's in centimeters. We may have to convert that to meters when we go to calculate the cross-sectional area if we want our area to come out in meters squared. All right, I'll leave that for you to figure out. The cross-sectional area is going to be the area of a circle because the wire is actually tubular. So pi r squared is the area of a circle, so take that into account when figuring out the cross-sectional area. Next then, it says set the power supply to 4 volts, set up a multimeter to measure the current, and measure the current through various lengths of the wire as indicated by the data table. Alright, here's the setup. We've already set the power supply to measure 4 volts. To measure the current, we're going to use this as set to measure as an ammeter. So we turn the dial to measure DC amps, in which case this terminal has to move from here over to here. We'll look at these a little bit more later down the road, but now we're set to measure amps. So what we'll do is we take the cord from the power supply, set it to the 0 spot on the wire, which is tacked down to a board that has a little bit of a meter stick on it, and then we run current through that to the meter and then back to the power supply. So this right here is going to measure the current that's flowing through the wire at various lengths on this. All right, so what we're going to do is start at the end, and then we'll work our way down to a shorter and shorter length on it. Okay, it looks like in our data table here, we're going from 0.04, 0.08 up by increments of 0.04. The last one then, it looks like should have been 0.30. Let's change that, 0.30. That's where we'll start, 0.30. All right, so I'm going to put the electrode right at 30 centimeters and the current 0.29. All right, so we'll write that in here. Current 0.29. All right, that's in amps. Now we're going to go a little shorter. 0.28. 0.32. 0.32, a shorter piece, so the current went up. 0.24. 24 centimeters. 0.35. 0.35. 0.20. 20 centimeters. 0.40. 0.40. 16 centimeters, 0.51, 0.51, 12 centimeters, 0.63, 0.63, kind of jumps around a little bit sometimes, 8 centimeters, 0.84, 0.84, 4 centimeters, 1.38. Let's go with 1.38. 1.38. Now when we get to the short end there, it heats up the wire a lot and it kind of jumps around a little bit because the resistance of it is actually influenced by temperature as well. We'll talk about that a little bit more later. But let me show you something toward the end there. Notice that down here toward the end, it looks like it kind of burned the paper. When I go at 4 centimeters, the wire gets pretty warm, 1.38, and if I get shorter, the current gets a little higher, and notice that the wire is starting to get red hot and can actually burn the paper. All right, we're going the real short little piece and the wire gets red hot. That's why we use this kind of wire in things like toasters and hair dryers, because the wire can get very hot when you run current through it. Okay, so we have our data. The voltage, remember we just set that to be 4.0 volts, and that just remained the same the entire time. The third column on the data table now is the length divided by the area, and you'll have to calculate the area in meters squared. And then the last column is resistance. We can use Ohm's law to figure out resistance. V divided by I, R equals V divided by I, and that'll be the resistance of the wire at those various lengths. And then we're going to make a graph out of this to try to determine the resistivity. The resistivity is this Greek letter called rho. So we're trying to figure that out. So if we graph this on the x-axis and this on the y-axis, then the slope of the graph should be rho. All right, so okay, the remainder of this then we'll leave for you to make a graph, and you probably want to use something like Excel or Google Sheets to make a graph so that you can get a best fit line, and the slope of that line is going to be the resistivity experimental value. And then we'll compare that to the textbook value, which we talked about in class, and then we can figure out, say, our percent error. So when you make a graph, then copy and paste that into this area before you Dropbox the lab report.